We're going to talk a little bit about combinations and permutations. Now, what these essentially are ways for counting things. So if you have, let's say, n things available, that could be 10, and you're selecting r things from that group of 10. So let's just say you have 3 and 10. So the question usually is, how many ways can you pull 3 items from this 10 so that you capture all possible basically all possible ways you can draw 3 things from 10. So one thing to review is factorial notation. We call it factorial notation as 10 factorial would be 10 times 9 times 8 times 7 times 6 times 5 all the way down to 1. And whatever factorial it is, you multiply all the way down by whole numbers until you reach 1. By definition, 0 factorial equals 1. So if you try to do that in your calculator, it's not 0 because if you think about it, there's always one way to order 0 things. That is, you don't order them at all. But that does count as one way, so that's kind of the intuition behind that. So permutation looks at all orderings. So even arrangements of the same r things. So suppose you draw A, B, and C. Well, that might be one possible ordering, and maybe it goes, those are the 3 things that you're drawing. They're the first 10 letters. But this also considers B, A, C, C, B, A, and all the other ways you can do this, they count those as unique possibilities. So if you think about it, if these are positions, like this would be first place, second place, and third place, well, it probably makes a difference whether A is in first, second place, or third place. In combinations, the ordering does not matter. So let's just suppose these are 3 prizes, and that all the 3 prizes are equal. In that case, you might treat every possible arrangements of these 3 elements as being identical. That's what we mean by combination. And of course, this is how we calculate them. We won't actually be doing this by hand because as soon as n and r get fairly large, the calculators sort of blow up and don't really do a very good job computing these things. So let's develop a little bit of intuition behind these formulas. So suppose that you have 3 jackets, and you never want to wear the same jacket on 2 separate days, but you're looking at your wardrobe for the next 2 days. So you've got jackets 1, 2, and 3. Well, on day 2, you can really wear either jacket 1, jacket 2, jacket 3, jacket 1, jacket 2, jacket 3. But again, we don't necessarily want to wear the same jacket again. So our number of possibilities has gone from 3 down to 2 on the second day because we're not going to rewear the same jacket. So you'll notice that what we have here is we have 3 possibilities for the first try, and each of those branches out into 2. Well, that's just the same thing as 3 times 2, which gives us 6. Well, okay, so that works fairly well. All we need to do is figure out the number of things for the day 1, multiply it by the number of things for day 2, since each one of those branches out into 2 limbs of this tree, and this gives us the total possibilities of 6. Well, alternatively, you'll notice that in this case, the ordering is being considered because I may consider it different to wear my jacket number 1 on day 1 and my jacket number 2 on day 2 versus jacket 2 on day 1 and jacket 1 on day 2. So right now we're thinking of those as unique possibilities because they might be. They might just go with the pair of pants you wear better. Well, if you notice, if you do so we have 3 things, and really we're taking order into consideration, so we're doing a permutation, and out of those 3 jackets we're going to be wearing 2 of them. We're not going to be repeating the same one. So we would do 3 permutation 2, or 3 permute 2. And look at that, we get 6. So that takes the order into account. And these are both identical ways you can do it. So anytime you're dealing with permutations, you can use either of these methods where you either multiply by hand or use the permutation. Now suppose you had 15 jackets in 10 days. You probably